Okay, so here we go with some extra practice of graphing sine and cosine. This is a pretty important topic for us, so we're going to spend a little extra time on it. So this first one here has us graphing y equals 3 sine of theta minus 1. So the first thing we want to do here is think about which one we're graphing, which in this case is sine. And we're going to think about what are those 5 important points for a sine curve. Okay, so as we listed them, intercept, max, intercept, min, intercept. And the sooner we kind of get to know those, the easier this graphing process will get. Second, we want to observe what our transformations are. So in this particular case, we have a stretch of 3, that's an amplitude, and we have a downshift of 1. Okay, that's going to be our new midline or our new x-axis. All right, so when I get to the actual graph, the first thing I want to do is graph that downshift of 1. So I'm going to put a dashed line at -1. Now, I really want to try to imagine that as my new x-axis. Okay, so the old x-axis doesn't really mean anything right now. Okay, and in sine, my first point that I plot is going to be an intercept. So the intercept of the y-axis and my new x-axis. All right, the period for a sine curve is 2 pi. All right, so that means that my last point that I plot is going to be 2 pi blocks away. Now this is easy because there's no horizontal shift here. So I simply go over to 2 pi blocks and put my last point, which is also an intercept. Now everything from there works in halves. So the middle point will be halfway between those 2 points, which is also an intercept. Okay, and then halfway between the first 2 intercepts is the maximum. Now I got to be careful here. The maximum for this one is 3 above the midline, since that's the amplitude change. 1, 2, 3. Okay. And then after that, I have the minimum. Okay, which would be 3 below the midline. 1, 2, 3. And that gives me 1 complete cycle of my sine curve. Now, obviously, I could continue that pattern into the negative side of the angle measures here if I wanted to. But on a test or a quiz, we're asking for 1 complete cycle for full credit. But that's what the curve would look like. I'm going to do another example for you here, and then ask you to do a couple sine curves on your own. All right, so here we go. This sine curve, again, intercept, max, intercept, min, intercept. All right, I'm going to jot that down because I'm going to reference that, okay, during this process. As I plot these points, I'm going to try to cross them off. All right, so I know which point that I'm on. Now I want to look at what my 2 transformations are. In this particular problem, I have a horizontal compress, all right, which in this case we call frequency change, and then I also have a downshift of 3. All right, so how does this frequency change affect the graph? Well, the normal period for a sine curve is 2 pi. If we divide that by the b value, which is the frequency, we will get the new period. Okay, so 2 pi divided by 2 is going to give me pi for my period. That's important. Okay, that means my first point is an intercept. My last point is at pi, not 2 pi for this particular curve. Okay, which means my middle point is going to be at pi over 2, right? Because that's halfway between this point and this point. So let's take a look at what it looks like in action. So down 3 is first. That's easy. That sets my midline. Okay, my sine curve still starts at an intercept. So I'm still starting it at the intercept, okay, which would be the intersection of the x-axis and the y-axis. My last point, though, is now only going to be pi units away because of the frequency change. All right, so I have my first point and I have my last point. All right, the point in between them is the intercept again. So halfway in between those 2 is my last intercept. Now, between the first 2 is my maximum. All right, there's no amplitude change here, so it's just 1 above. and 1 below. Okay, so notice how that graph has been horizontally compressed. Okay, now I could also look at it a different way. I can continue this curve, all right, continue this pattern all the way to 2 pi, and that might make this frequency concept a little clearer, because if I count how many times my curve happens, okay, I will see that it happens 1 and 2 times, okay, over 2 pi, which is the meaning of the frequency. All right, so I have a few more for you to do here. All right, actually, we'll do one more together. Let's do one of these that has all the shifts involved. Okay, so this last one here. All right, so we have multiple shifts now going on. Okay, we have amplitude of 3. We have horizontal shift, okay, pi over 4, and we have downshift of 1. All right, so like always, I'm going to start with those, that midline, that downshift of 1. I'm going to graph that first. That's my new x-axis. Okay, then I'm actually going to graph the horizontal shift second, and that'll be my new y-axis. So remember, a plus sign is counterintuitive, means to the left, and pi over 4 is going to be half of pi over 2, right? 1/4 is half of a half. So that's actually going to give you my new y-axis. So I'm essentially drawing a new plane here, okay, using the new x-axis, new y-axis with my shifts. Now I can ignore the old x-axis and the old y-axis because I have the new ones. So I'm going to go ahead and plot, right? Remember, intercept, max, intercept, min, intercept, okay? So first point first. Intercept. It's the intersection of the new x-axis and new y-axis. The last point is also an intercept. Okay, and because I don't have any period change, it's going to be 2 pi from the first point. Now be careful. 2 pi here is 1, 2, 3, 4, 5, 6, 7, 8 blocks. I cannot go to 2 pi to plot the point because I've had a shift. So I'm going to go 2 pi from that first point, which is 8 blocks. 1, 2, 3, 4, 5, 6, 7, 8. So there's my last point. That's very important that you pay attention to that detail. All right. Now my middle point is also an intercept, so halfway between these two. 1, 2, 3, 4. All right, and halfway between the first two is my amplitude of 3. 2, 3. Halfway between these two, 1, 2, 3. And I will have one complete cycle of my sine curve. And all these parts here sort of help the process. So what I'd like you to do is go ahead and pause this video, and I want you to complete those other 3 sine curves and compare your answers to the key when you're finished.